The filtering using bound consistency on some numerical values. We have three variables, x1, x2, x3, and we want the sum of these variables to be equal to 0, and we will study the propagation on x1. Therefore, we put x1 completely to the right of the equation here to do the bound reasoning. We have x2 plus x3 equal minus x1, and the corresponding domains are these ones. Of course, here, because you have minus x1, you will assume here that you have the y variable that is a view on minus x1, okay? And so minus x1, you just here have minus this domain, so this interval, and so you will just flip, so minus 10 is the new minimum, and 100 is the new maximum, because we have minus 100, which is 100. Okay, so this is the domain of the y variable, that is the one that is on the right of the equation here. Then we will want to apply the filtering, so we will just do some bound addition here. If you add two intervals, the new interval, the resulting interval, you just take the minimum, the sum of the two minimums. So you've got 24, you've got 60 plus 6, so 66. And here it was already a single interval, so you've got this. You want to make these two intervals equal, so you take the intersection of the two intervals. Okay, so the domain of y is the intersection of these two intervals, and so the resulting domain is this one, 24, 66. Okay, which is completely inside this one, so that's the new intersection. But if you remember, that's for the domain of y, so if you want to convert it back to the domain of x1, you just need to take the opposite of that, and so the domain for x1, the new updated domain after the filtering, is minus 66, minus 24. Okay. We can design a filtering algorithm for the sum constraint. The consistency check simply consists of summing the minimum and the maximum of the domains of all the variables, and we just verify that 0 belongs to this interval, because we want the sum of the n variables to be equal to 0. Okay, we can do this consistency check in theta of n, that's the time complexity. If you want to filter one variable such as xi, the domain of the minimum, and you want to update it, you need to take the sum of the opposite of all the variables except the variable I. Okay, this is exactly what we do here. And for the maximum, you do the opposite. You do the summation of the minimum of the domains, and of course you take a minus here, because you would put that one to the right. Okay, that's the same as what we did before for the filtering. Okay. That would require theta of n for each variable, okay, just to take the sum here of the opposite of the domains. That would be theta of n for each of them. The question is, can we do better than that? Can we do something that is faster overall? Because that would take n squared for all the variables, right? Okay, that's quite expensive. Can we do better and have a linear time complexity for all the variables? The answer is yes. We can pre-compute in theta of n the sum of the minimum. I would store that inside two variables, smin and smax. Okay, smin will store the sum of the minimum of the variables, and smax will store the maximum of the domains of the variables. The consistency check, just checking that the constraint is feasible, amount at verifying that 0 belongs to this interval. Okay, and then I can filter the domain of each variable once this is pre-computed, right? Once this is pre-computed, the update rule of the minimum and the maximum of the variable is simply the maximum between the previous minimum and minus s max that you have pre-computed plus xi max. Why am I doing that, adding back xi max? Because if you remember the previous slide here, I need to take the sum over all the variables except xi, right? Because this is the one that I'm filtering. And so to cancel the contribution of the variable I to this S max, I just add it back here, okay? And I do the same here. The very nice idea is that by pre-computing these sums, I can then filter all the variables in constant time, constant time per variable. And so overall, my time complexity to filter all the variables is theta of n once I have pre-computed these sums. So that's much better than the previous n squared time complexity. In the next video, we will explain the all different filtering algorithm.